Hello students, in today's video we'll do miscellaneous exercise on chapter 2, questions 7 to 12. Question number 7. F, G, R to R be defined such that f of x is equal to x plus 1, g of x is equal to 2x minus 3. Find f plus g, f minus g and f by g. So f of x is x plus 1, g of x is 2x minus 3. Find f plus g. That means add the functions f of x and g of x. F plus g means just add them. So f plus g of x. So that is f of x plus g of x. So x plus 2x is 3x. 1 minus 3 minus 2. Second, f minus g means subtract f of x minus g of x. F of x is x plus 1 minus g of x is 2x minus 3. So x plus 1 minus 2x plus 3. So x minus 2x, 1 plus 3. So minus x plus 4. F by g means divide f of x and g of x. So f of x by g of x is x plus 1 by 2x minus 3. The condition is, you have to write the condition here. The denominator should not be equal to 0. G of x should not be equal to 0. What is g of x? 2x minus 3. So 2x minus 3 is not equal to 0. That means this f by g is defined only if x is not equal to 3 by 2. If x is 3 by 2, the denominator becomes 0, then the function is not defined. Now we'll move on to the next question. F is defined as 1, 1, 2, 3, 0, minus 1, minus 1, minus 3 be a function from z to z defined by f of x is equal to ax plus b for some integers a, b. Find a, b. A function, it is given f is a function. F is a function from z to z. Z is set of integers. And f of x is ax plus b. Find a and b. It is a function. It is given, it is a function. So it is here 1, 1. The ordered pair 1, 1. 1 is x. And this is the 1 is the input. And this 1 is the output. When you give x as 1, you get f of x as 1. This is the output. When x is 1, the output is 1. 2, 3. That means when x is 2, f of 2 is 3. Okay, when x is 2, that means when the input is 2, the output is f of 2. So this is 2, 3 means this is actually x, f of x. So this is the domain, this is the range. So 1, 1. So 1 is the input, this one is the output. We need to find a and b. There are two integers we have to find. So let us take this one first, 1, 1. That means x is 1. F of 1 is also equal to 1. So the function f of x is ax plus b. Put x is 1. So when x is 1, f of 1 is 1. What is f of 1? Substitute x as 1. So a plus b is equal to 1 because the range is 1, the output is 1. When the input is 1, the output is 1. So a plus b. A in the place of x you put 1 plus b is equal to 1. F of 1 is 1. So this equation 1. You can take 2, 3 or you can take 0, minus 1. The input x is 0, f of 0. So this is 0 and this is f of 0. This is the output. If the function is represented as an ordered pair, the first values will be the domain. The second values represent the range. So 0 and this is f of 0. X is 0. f of 0 is minus 1. So f of 0 means substitute x as 0. So a 0 plus b. The function is ax plus b. So a 0 plus b is equal to minus 1. So b is minus 1. So because I took 0 and minus 1, I got b as minus 1 straight away. Or if you take 2 and 3, you get two linear equations. You have to solve. You can do like that also. Or you take this. So you'll get a linear equation, solve it. So we are here, we got b as minus 1. Now because b is minus 1, substitute b as minus 1 here. So a minus 1 is 1. A minus 1 is 1. So a is equal to 2. So we got a is 2, b is minus 1. That's the question here. Find the integers a and b. Now the next question. Let R be a relation from n to n. R is a relation from n to n. N to n means from natural numbers to natural numbers. R is defined as the ordered pair a comma b. A, b belongs to n and a is b square. The first element is the square of the second element. So a is b square. The first element. So it is like 4 comma 2. Like that. That means the first element is the square of the second element. Now, question is, are the following true? First one, a comma a belongs to R for all a belongs to n. Is this true? That is, if a and b are equal, a comma b is the relation given. If a and b are equal, will that ordered pair belongs to the set R. So what is the condition? A comma b, a should be equal to b square. If this statement is not true for one case, then that statement is a false statement. If it is not true even for one case, then it is a false statement. If it is true, if you are saying it is true, it should be true for all cases. In general, it should be true. So let us take one example. It's a very simple one, a comma a. Let us take a natural number, 3 belongs to n. We have to check if 3 comma 3 belongs to R. The first element should be the square of the second element. It is not possible. 3 is not the square of 3. Okay, a is equal, they are given a should be equal to b square. So it is not true, it is not possible, because never. Only in the case of 1 comma 1, only you can say 1 comma 1, it is true. If you square the second element, you get the first element. So only 1 comma 1, it is true. So it is not a true statement. A comma a belongs to R for all a belongs to n is not a true statement. Now the second one, if AB belongs to R, that means if A is equal to B square, can you say that B is A square? The first element is equal to the square of the second element. So let us check. One example if you give, it is not true is enough. We are going to give one example here. 16 and 4. You know that 16 comma 4 belongs to R. Why? The first element is the square of the second element. That's A. This is B. When you square B, you get A. So this belongs to R. Now the question is, you reverse the order. If you reverse the order, is AB, if you write as BA, does that belong to R? This is, if you square this 16, the second element is 16 now. If you square this, you won't get 4. So 4 is not equal to 16 square. The second element, if you square, you should get the first element. Still, when you square, you're not getting 4. So if AB belongs to R, doesn't mean that BA belongs to R. So this statement is also not true. Now the third statement, if AB belongs to R, BC belongs to R, implies that AC belongs to R. The second element of this and the first element of this ordered pair are equal. So you should give an example like that. So we're going to give an example. We take the same example. 16 comma 4 belongs to R. Is it? Yes, because when you square the second element, you are getting the first element. So 16 4 belongs to R because 16 is 4 square. Now start with 4. Okay, the first element should be this 4. This is how they are given here. AB, BC belongs to R. So BC. So 4, 2 belongs to R. Yes, because when you square the second element, you are getting the first element. Yes, but the first and the last, if you take the first element of this and the second element of this, that ordered pair, will that ordered pair be in R? The 16, 4 belongs to R. Because you square this, you are getting 16. 4, 2 belongs to R, because when you square 2, you get 4. The question is, if you take the first element of this and the second element of this and you form an ordered pair, will that be in R? 16, 2, no, because if you square this 2, you won't get 16. Isn't it? 16, the second element, if you square, you're not getting 16. So 16, 2 doesn't belong to R. So AB belongs to R, BC belongs to R, doesn't mean that AC belongs to R. The statement is not true. Now we go to the next question. Question number 10. If A is 1, 2, 3, 4, B is 1, 5, 9, 11, 15, 16, F is given like this. So F is a set of ordered pairs. 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. The question is F a relation from A to B? When will you say F is a relation from A to B? If F is a subset of A cross B. So the relation is a subset of the Cartesian product. The relation is taken from the Cartesian product. All the elements of the relation should be there in the Cartesian product of A cross B. So first we have to find A cross B. A cross B is the Cartesian product of the sets A and B. So what is A cross B? Set of all possible ordered pairs. All possible ordered pairs we have to write. So which are the ordered pairs? 1, 1, 1, 5, 1, 9, 1, 11, 1, 15, 1, 16. Then you start the 2, 2, 1, 2, 5 up to 2, 16. Then you start the 3, 3, 1, 3, 5 up to 3, 16. 4, 1, 4, 5, 4, 9 up to 4, 16. So we have written all possible ordered pairs. Now we have to check if this F is a subset of this. That means we have to check each and every element of F is present in A cross B. Each and every element of F we have to check whether it is present in A cross B. So 1, 5, yes, it is there. 2, 9, yes. 3, 1, yes. 4, 5, yes, yes. 2, 11, yes. So each and every element of F is present in A cross B. That means B. F is a relation from A to B. Why? Because F is a subset of A cross B. So F is a relation from A to B. Next is it a function? When will you say it is a function? If a relation is expressed as an ordered pair, you can easily check if it is a function. How? You should not have the same first element. 2 if you take, you have the 2 here also. So the same first element is 2 here, here also it is 2. So it clearly says this is not a function. So in other words, you can say the element 2 has 2 images. 2 has 2 images, 2, 9 and 2, 11. So if it is a function, each and every element should have a unique image. You cannot have different images. So because element 2 has 2 different images, as element 2 corresponds to 2 different images, 9 and 11, it is not a function. So 2 has 2 images, it goes to 9 and also to 11. So this is not a function. Question number 11. F be the subset of Z cross Z. Z is set of integers. It is a subset of. That means F is a relation. It is a subset of Z cross Z means it is a relation. Now defined by AB, A plus B is this relation f a function from z to z. Is this a function? Justify your answer. So let us check. It is an integer, set of integers. So we can easily check this by taking an example. We can easily say this is not a function by taking one example. Okay, so as I told you, if you're going to say it is not true, one example you give, that's enough to justify your answer. Just one example. Suppose you multiply two positive integers and two negative integers, you get the same answer. The product will be the same. For example, you take 2 and 4, minus 2 and minus 4. When you multiply 2 into 4, 8. Minus 2 into minus 4 also gives you 8. So the first element, you cannot have the same first element a, b, because a and b are integers. If I take a as 2 and b as 4, then a is minus 2 and b as minus 4. You get 2 into 4, 8. 2 plus 4, 6. Minus 2 into minus 4, 8. But when you add, you get minus 6. That means 8 has two images, 6 and minus 6. You will have so many elements like that. If you take minus 3 and minus 4, you will get 12. If you take minus 3, minus 4, this is one, minus 3, minus 4 as z, ab as minus 3, minus 4, and plus 3 plus 4 will give you 12. And when you add, you get minus 7. And here when you add, you get plus 7. So this 12 has two images. So you can find so many examples like this. So this clearly says it is not a function because element 8 has two different images, 6 and minus 6. So this is not a function. Next, question number 12. Let A is 9, 10, 11, 12, 13. F is defined from A. A is the set A. N is a set of natural numbers. And f of n is defined as the highest prime factor. So what is the set A? 9, 10, 11, 12, 13. And A to n. That means the input, the domain is A. And this is the codomain. Okay. So we have to find the output. Range means the output. So this is the codomain. So we have to find the range. So range means what output will you get. So what are the prime factors of 9? Prime factors of 9, only 3. 3 is the only prime factor. 2 and 5. So prime factors of 10, 2 and both are prime numbers. Prime factors of 11, only 11. Prime factors of 12, 2 and 3. Prime factor of 13, but the output, what did they say? The highest prime factor. So that means the highest prime factor of 9 is 3. This is the highest prime factor. The highest prime factor of 10 is 5. The highest prime factor of 11 is 11. The highest prime factor of 12 is 3. And this is 13. 3, 5, 11, 13. So the range of f is a set of all f of n. This is the output. So range is the output. What are the output values you get? 3, 5, 11 and 13.